Okay, so we ended yesterday really after a review of the sine, cosine, and tangent values that you should be familiar with from last year. I know it takes some refreshing, but we're also just going to jump right away into our reciprocal functions, which is still a review from Algebra 2, but it was a little less focused on in Algebra 2, so we'll do a little more of it definitely in PreCalc. Cosecant is the reciprocal of your sine function. So anytime you're asked for the cosecant value of something, at least in my mind, I think of the sine value of it and then just flip the fraction. If I'm asked for a secant of some value, I find the cosine value, because those are the ones we're most familiar with, and then I just flip it in my head. And then cotangent is 1 over the tangent. So for example, with cosecant being 1 over the sine, if I'm asked for the cosecant of 0, I think of the sine of 0, which is 0, and then I flip it. And a 0 flipped is undefined. For the cosecant of 30, I would think of the sine of 30, which is 1/2, and then when you flip 1/2, it would become 2. The cosecant of 45, I'd think of the sine of 45, which is root 2 over 2, and then when you flip that, it becomes 2 over root 2. Now this one, though, requires a little work because it has to be rationalized. You'd have to multiply by root 2 over root 2, which gives you 2 root 2 over 2, and then your 2's will cancel. So it'll all just boil down to root 2. So I'm going to erase all that work and just show root 2. For the cosecant of 60, I know the sine of 60 is root 3 over 2, so that would be 2 over root 3. That needs to be rationalized, so multiply by root 3 over root 3, and I get 2 root 3 over 3. For the cosecant of 90, the sine of 90 is 1, so the cosecant of that is 1. Now, with my other angle measures, I like to think of my sine picture. So obviously 0 to 90 just brought us through the first quadrant. So the sine of 0 is 0, and the sine of 90 brings you up to 1. And then it's going to decrease back down to 0, and keeps decreasing to -1, and then increases back to 0. So the opposite poles are 0, and then the opposite poles are 1 and -1. So now if I'm asked for the cosecant of 180, well, I know the sine of 180 is 0. So the reciprocal of that, the cosecant of that, is going to be undefined. For the cosecant of 270, I'm going to think of the sine of 270, which is -1, and the reciprocal of -1 is -1. And then for 360, that's just going to follow your 0-degree angle because they're coterminal, so that'll always be the same. Okay? So the table looks a little bit different. I wouldn't memorize this table necessarily. I actually wouldn't at all. The only table I memorize is the sine, cosine, and tangent values, and then anytime I'm asked for any of these, like I just showed you, if I'm asked for the cosecant, I come up with the sine, because I don't see the point in memorizing two tables. I know the sine value, and then I just flip that value. Sometimes I have a little extra work of rationalizing. That's whatever. For secant, I'm always going to come up with the cosine values first and flip them. For the secant of 0, I'm going to do the cosine of 0, which is 1, and when I flip that, it's 1. For 30 degrees, I'm going to first come up with the cosine of 30, which is root 3 over 2, and then I'm going to flip root 3 over 2 into 2 over root 3, which we already rationalized, and it actually became that one. So I'm just going to write 2 root 3 over 3. I don't need to rationalize the same thing that I already rationalized a minute ago. For 45 degrees, the cosine of 45 is root 2 over 2. So the secant of root 2 over 2 of that would be 2 over root 2. Just flip it. And then when you rationalize that, again, we don't need to redo that. We already did it once. It's just root 2. The cosine of 60 is a half. So to flip that, we get 2. And the cosine of 90 is 0. Flip that, you get undefined. And again, for the rest of these, I'm going to think of my cosine image. At least this is what my mind thinks of when I am asked about the angles that are on axes and not actually in a quadrant. So the cosine of 0 is 1, and it drops to the cosine of 90, which is 0. And then this one, because it's opposite 1, would be negative 1, and this cosine value is 0. So again, it's 0 on opposite poles and 1 and negative 1. They're just flip-flop from what the sine ones are. So if I want the secant of 180, I'm going to take the cosine of 180, which is negative 1, and flip it. Still negative 1. If I want the secant of 270, I'm going to find the cosine of 270, which is 0, and flip it, which is undefined. And if I want the secant of 360, well, that's going to be the same as the secant of 0, so 1. Okay, and lastly, our cotangents, which I'm going to think of the tangent values first and flip them. So if I do the tangent of 0, it's 0. That flipped is undefined. The tangent of 30 is root 3 over 3. So when I flip that, that's going to become 3 over root 3. It needs to be rationalized. 3 root 3 over 3. So it's just going to be root 3. For 45, the tangent of 45 is 1. So the reciprocal of 1 is 1. That's nice and easy. The tangent of 60 is root 3, which has a reciprocal of 1 over root 3. Rationalized becomes root 3 over 3. And then the tangent of 90 was undefined, which is a number over 0. If you flip that, then that becomes a 0 over a number. So the reciprocal of undefined is a 0. Just like the vice versa, the reciprocal of 0 is an undefined. And then to get to my other non-quadrant angles, my tangents go from 0, and then they increase indefinitely until undefined. And they decrease back down to 0, and then undefined again. So, for cotangent of 180, well, the tangent is 0, so the cotangent would be undefined. For 270, the tangent, that's my tangent graph. The tangent of 270 is undefined, which means my cotangent is 0. And for 360, my tangent is 0, which means my cotangent is undefined. So I don't anticipate you'll ever have to fill out that table again. It's just any time I call on cosecant, secants, or cotangents, I think of my sine, cosine, and tangent values and flip them. Okay, so here we are. So we've got two trig functions. The sine is 2/5. And the cosine is root 21 over 5. Find the value of the 4 remaining trig functions. So the first primary three are sine, cosine, and tangent. To find the tangent, you just do sine over cosine, traditionally. So the sine is 2/5 over the cosine value is root 21 over 5. Hopefully you remember that from yesterday, and also from last year, that tangent is just the sine over the cosine. So fraction divided by fraction, we're going to keep, change, flip. Our 5s will cancel. We have 2 over root 21. We rationalize. Root 21 over root 21 makes 2 root 21 over 21. The next three functions are just going to be coming from reciprocating each of these. So the reciprocal of sine is cosecant. I always remember that because it's not the same letter. Sine is S, cosecant is C. But the cosecant of x is just going to be the flip of the sine, so 2/5 easily becomes 5/2. Cosine's reciprocal is secant. Again, that's a C, so that has a reciprocal of an S. Would flip to 5 over root 21, which needs rationalizing, so root 21 over root 21. So we've got that one's reciprocal, and now we want this one's reciprocal. So the reciprocal of tangent is cotangent. Now, we were here, and that is the value of tangent of x. We just had to clean it up and rationalize. However, if we reciprocate this version of it, we're going to have to re-rationalize. We'll actually be better off reciprocating this earlier version of it that we hadn't yet rationalized, because if we reciprocate that one and the root 21 goes on top and the 2 goes on the bottom, now we don't have to re-rationalize and we just save ourselves some work. If you did reciprocate this one and re-rationalized it, once that radical popped to the bottom, it would end up the same. It would just take a lot longer. So I just go back and find the version of it prior to us rationalizing, because the radical was in the denominator, but when you flip that version, now the radical is in the numerator and you're all set. Okay, for number 2, gives us sine and asks for the remaining 4 trig functions, which is interesting because I would say that there are 5 more. We can find all 5. This one's a little different because we're not given 2 to start. So when we're only given one of them, sine is positive. And if you remember from last year, all students take calculus. All the functions are positive here. All the functions are just the sine function is positive here. And since the sine is a positive number, it has to be in quadrant 1 or quadrant 2. Let's just treat it as quadrant 1 right now, just for the sake of keeping it straightforward. So we have an angle in quadrant 1. We always create a triangle, a right triangle, with the x-axis. Your x-axis is your big reference axis. So that's where your right angle would go, and your angle x is there. So from SOHCAHTOA, which you should remember from algebra and geometry, sine is opposite over hypotenuse. So the opposite side over the hypotenuse side is 2/3, which means this is your opposite, and 3 is your hypotenuse. So your opposite is 2, your hypotenuse is 3. Let me get rid of that A. And so with those 2, given that this is the right triangle, we can find the third side length from the Pythagorean theorem. A squared plus B squared equals C squared. So 2 squared plus B squared equals 3 squared. Subtract your 4 from both sides. 9 minus 4 is 5. Square root both sides. B equals radical 5. And that's that side length. So even though we're only given one function value, it gives us enough to create a triangle, to complete the triangle, and then we can go on and find the cosine, because that's just the adjacent, root 5, over the hypotenuse 3. And we can find the tangent, because that's just the opposite over the adjacent, 2 over root 5, which gets rationalized into 2 root 5 over 5. So there's sine, cosine, and tangent. And if you have all those 3, then you can definitely find the other 3 just by flipping them. So the reciprocal of sine is cosecant. Flip 2/3 to 3/2. The reciprocal of cosine is secant. Flip root 5 over 3 to 3 over root 5. And rationalize 3 root 5 over 5. And then for cotangent, we'll flip tangent. Now, again, you can flip this version of it, but you'll have to re-rationalize once that radical goes to the denominator. Or you can take this version of it and just flip that into root 5 over 2. And then we have all 6 trig functions. So I really think that should have said the remaining 5. Alright, for exact values. Again, I'm going to find my exact value of the reciprocal one, and then I'm just going to flip it. So to find the cotangent of 5 pi over 4, I'm going to first find the tangent of 5 pi over 4, which is, it's over 4, so this is a 4 pi over 4, which means a 5 pi over 4 is down here. So number one, all students take calculus, is that tangent value going to be positive or negative? Since it's in a T quadrant, it's going to be a positive number. The reference angle is 1 pi over 4, and our tangent of pi over 4, you should have memorized, is 1. So if the tangent of 5 pi over 4 is 1, then the cotangent of 5 pi over 4 is the reciprocal of that. So if that's 1, the reciprocal of 1 is 1, and you're done. For the cosecant of 5 pi over 6, the reciprocal function is the sine, so I'm going to find the sine of 5 pi over 6 first. Given that we're over 6, I'm going to label this 6 pi over 6, which is going to tell me my angle is right here in the second quadrant, 5 pi over 6, because as I come around the unit circle, I hit it there. All students take calculus, so the sine in the S quadrant is also going to be positive. The reference angle from 5 pi over 6 to 6 pi over 6, the reference, pi over 6. So I already know it's positive. What's the sine of pi over 6? From your memorized values, sine of pi over 6 should be 1/2. So the sine of 5 pi over 6 is 1/2. So to find the cosecant, reciprocate 2. The majority of the work is in the skill that we learned yesterday, or reviewed yesterday. And then you just get to the end and you flip your answer. Alright, secant of negative 9 pi over 4, I'm going to find the cosine of negative 9 pi over 4. And once I get it, I'll flip it. So, negative 9 pi over 4. So we're going backwards because it's a negative. So here's negative 4 pi over 4. Keep going a full circle is going to be negative 8 pi over 4. And so negative 9 pi over 4 is just going to be one extra tick past. So, if we're the cosine in that quadrant, it just so happens that it's going to be positive again. That's our positive quadrant for cosine. And the reference angle is pi over 4. So what is the cosine of pi over 4? Root 2 over 2. Now, reciprocating root 2 over 2 becomes 2 over root 2. Which will rationalize to 2 root 2 over 2, which is just root 2. Which we, did a lot of that rationalizing stuff of these values up here, so hopefully they become more familiar to you and you can kind of hurry your way through those. And then part D, which is, got a lot more to it, asks you for all of these values. But we're also doing operations with them. Now, some of these we've already thought through the process, so like I'm just going to steal values from my table. If I didn't remember, I would find the sine of 60 degrees, because pi over 3 is 60. I would do the sine of 60, I'd flip it. I'd do the cosine of pi over 6, or the cosine of 30 degrees, and flip it for this one. And that one is a tangent, so that's what we like. But the work has already been done. Pi over 3 are 60-degree angles. So the cosecant of pi over 3 is 2 root 3 over 3. So just 2 root 3 over 3, stolen straight from my table. The secant of pi over 6 are your 30-degree angles. So the secant of pi over 6 is 2 root 3 over 3 as well. Plus 2 times the tangent of pi over 4, you should have memorized, is just 1. So when I multiply these, 2 times 2 is 4. Root 3 times root 3 is just 3. Or you could say it's root 9, but root 9 is just 3. And on the denominator, 3 times 3 is 9. So that's going to be 12 ninths plus 2. And 12 ninths is 1 1/3 plus 2. So that's going to be 3 1/3. So that one had like 3 parts. Would have been a lot tougher if it was 3 different parts we had to think about. But luckily, because we have that table near, we could just grab those values and go. Just quickly, because I'm thinking of it, the versions we used for these first two were rationalized. If you didn't have these and the chart wasn't sitting right in front of us, you would just think of the sine of 60, which is root 3 over 2, and flip it. Then you think of the cosine of pi over 6, which is the cosine of 30 degrees, which is root 3 over 2, and flip it. And then plus 2 times 1. And you would get 4/3, which is the same as 1 1/3. You'd get 4 on top, 2 times 2, over root 3 times root 3 is 3. You'd get 4/3. I'm working up here. And it would give you the same thing. So you don't have to use the rationalized version in and amongst the problem. Sometimes that kind of works this way out, like we saw there. Root 3 times root 3 in a denominator just becomes 3. You don't have to worry about rationalizing. So your homework is just a worksheet coming around. Let's see how much time that took. You should do the whole thing for homework. So if you didn't talk a lot in class, you should have about 15 minutes left, so you'll do the whole worksheet for homework.